Good afternoon to all of you. Now we start the reactions, that is oxidation reactions. Seen hydroxylation of alkene with KMnO4. So seen hydroxylation of alkenes by using the reagent KMnO4 and another reagent osmium tetroxides. So alkene undergoes the molecular additions of KMnO4 to form the cyclic permanganate and to form the cyclic intermediate. These on hydrolysis give the 1,2-glycol. The overall reaction is overall cyclic intermediate. This is on hydrolysis give the 1,2-glycol. This overall reaction is called as the hydroxylation of alkene. Syn hydroxylation of alkene is electrophilic addition reactions. So here's the reactions in which alkenes react with the manganese oxygen atoms, and the atoms involved in the reaction is the 2 carbon atom of the alkene and 2 oxygen atoms of the manganese, and form the 5-membered cyclic rings, which on the uh, addition of the water molecules converted into the glycol. How the reaction takes place of the alkene with the manganese is shown here. Manganese having the 4 oxygen atoms, one having the negative charge attached with the potassium. That negative charge involved in the resonance and attack on the alkenes. So alkene system is here. Now in this alkene, that oxygen is involved by the initiation of the oxygen atoms and the resonating structures involved in the formations. And in this way, manganese along with these oxygen atoms form the 5-membered rings in this way. So now the C oxygen manganese, and here is a stereochemistry also mentioned here. Okay, we can show the stereochemistry also, but because in manganese stereochemistry also shown here. So the next step for this is these oxygen atoms attached with the carbon atoms now break break with the manganese atoms and form the bonds with the carbon atoms and converted into the OH. So this OH is the reactions, how it is proceeds. In this way we get the final product, that is the glycols. Important notes is that because of the formation of the cyclic intermediate, both the hydroxyl groups are added from the same sides of the bonds. Hence this types of hydroxylation is called the cis or the syn hydroxylation. Stereochemistry of syn hydroxylation of the alkene is also most important. If the alkene has the unsymmetrical substitutions, then it will have the geometrical isomers, and hydroxylation of the cis and the trans isomer give the different diastereomers in the two faces of the alkenes are called as diastereotropic. Here is the mechanisms. So you do the practice of these mechanisms. We will discuss these mechanisms in the next lectures. Here the product is the mesotartaric acids as a products formations. Is the conversion of the Sauer's projection formula into the Fischer projection formula. This conversion is the most important. Okay, the lines COH and COH groups are on the vertical line, so it is mentioned on the verticals. And OH, H and OH is on the horizontal line, so it is mentioned on the horizontal lines.